Well, pre-calculus classes, once again, good morning, good afternoon, or good evening. We'll get started into section 2.3 here today. And the main thing that we're going to talk about and most likely review from last year with Algebra 2 is reviewing the concept of end behavior of a polynomial function. So, if you have any polynomial f of x equals x to the nth power, where n is a positive integer, or it could be 0, which is a constant function. But if n is even, it's going to look, as long as the largest power, I guess I should say, is even, the graph will have some similar characteristics to x squared, the parabola. If the largest exponent is odd, the graph is going to have some similar characteristics to x to the third, a cubic function. Now, one of the things that I'm going to do with these graphs here for today, I am going to initially plug them into a graphing calculator. Certainly, by the end of this, we will actually go over how to determine end behavior without a graph. So, if we look at the first one, f of x equals negative x to the fifth. Well, you can see, based on your parent functions, you end up with a cubic function. Really the only thing that, or a graph similar to a cubic function. The only thing that's really different, and again, I'm not going to be real worried about the shape as you draw this, it's a lot flatter as it goes through the inflection point. So the key things that happen though is, again, it is odd. You can see it looks similar to this. Granted, it does also have a reflection over the x-axis. So, which we'll talk about because that means it has a negative leading coefficient. But when we write our end behavior, we talk about two things. We talk about what happens as x approaches negative infinity. That is the left end behavior. We also talk about what happens as x approaches positive infinity. And that's an arrow there that didn't get drawn real well. Same thing with that one. So again, the arrow, we read it as x approaches negative infinity, and to the right as x approaches positive infinity. I'm not picky whether you want to use f of x or y there. You know, I realize, yes, it says f of x. If you would rather say y, that's certainly fine. You know, that isn't going to be something we're going to be picky about. Now, as you go to the left, you know, as you go off of the grid to the left, x is going to negative infinity. The x values are slowly getting smaller. Well, as we go off of the grid to the left, the y values are going up rather quickly. So, y approaches positive infinity. You can certainly write the positive sign in there if you want, but it's not needed. Now, as we go off of the grid to the right, again, x is to the right going up slowly. The y values, though, as we go off of the grid to the right, as x is going up, the y values are going to negative infinity. So there is the first one. Now, if we look at example B, h of x equals x plus 1 to the fourth, it's going to be shifted left 1. That's one thing that we can certainly mention right now. It still has that same transformation. And kind of like the x to the fifth, you can see it looks kind of like a parabola. The main difference is at the vertex, the graph's a little bit flatter. The higher the exponent, the flatter the curvature will be. So it's kind of, you know, like this and kind of like that. Now, again, the key things with this, once again, we're going to talk about what happens as x approaches negative infinity, and what happens as x approaches positive infinity. Notice you don't have to write left and right. It kind of is implied as x goes to negative infinity, that is to the left. Well, as we go to the left and go off of the grid, again, the x values to the left are always going to get smaller. Well, as we go to the left here, the y values are going up or approaching positive infinity. Now, when you have an even degree polynomial, as x goes to the right, the y values, x is going up to the right, the y values also go up to the right. When you have an even degree polynomial, the y and behavior characteristics will match. When you have an odd one, they will be opposite. Now, we'll talk about one or two other things with these next two examples as well. Now, if we look at C, g of x equals x to the 7th. Again, I'll go ahead and just get rid of that. And again, you can see you have, a graph similar to the cubic. Again, you can see that it looks like it's almost touching the axes for quite a bit. I mean, you do still have these three key points. Again, if you're really drawing it, looks kind of like that. Again, we're not going to be real worried about that. As x approaches negative infinity, as x approaches positive infinity. And as we do this, I am going to have this example here because we're going to talk about the differences and similarities. Well, as we go to the left, again, x is always going to get smaller to the left. The y values to the left approach negative infinity. As you go to the right, x again is always going to go up. The only thing that's possible to change is what happens to y. Well, as we go to the right, x is going up, y is also going up. So you can see when it's odd, the end behavior y characteristics are opposite. Same thing over here. The main difference is what happens with your leading coefficient. Here, our leading coefficient is positive 1. Here, our leading coefficient is negative 1. When it's an odd degree with a positive leading coefficient, the end behaviors match. Negative, negative, positive, positive. When it's odd with a negative leading coefficient, the end behaviors are opposite of each other. Negative, positive, positive, negative. And one last example that we'll talk a little bit about is an even. So negative 2x to the 6th. And when we graph it, two things happen. First, there is a reflection over the x-axis. There is also a vertical stretch. Again, you can see that the curvature of the parabolic shape is very flat around the vertex. So we end up with 3 points, kind of like that, and that. So as x approaches negative infinity, as x approaches positive infinity. Well, as far as what happens here, as x is going either left or right, well, both y directions are pointing downward. So both of the y's approach negative infinity. Well, again, if we look at both of our even degree polynomials. Here, our leading coefficient is -2. All that really matters is it's negative. Here, our leading coefficient is +1. When the degree is even, both end behaviors are the same. If it's even with positive leading coefficient, they both go up. If it's negative with an even degree, they are both going downward. So certainly if you want, and these last two we're going to do without graphing, but if you want to hit pause, try to list out the end behaviors before you finish watching, you can certainly do that. So again, here are the keys. Now, there is one other thing you do have to watch here. F of x equals -x to the 9th plus 4x to the 12th. Well, be careful. The degree is 12, which again, key thing is even. The leading coefficient is -1, and again, all we really care about is that it's negative. So, describe the end behavior. Well, as x approaches -infinity and +infinity, because it's even, they're going to be the same. It's even with a, actually, let me correct that, and this is where you do have to be careful. It's even and positive. So, because it's even and positive, they both approach +infinity. So again, do be careful when it's written out of order. I know I initially focused on that for the degree, and then almost had it written wrong for the leading coefficient. So even and positive, y's are both going up. Again, certainly if you want to hit pause for this last one, you can. Our degree is 7, which again, all we really care about is that it's odd. The leading coefficient is -2, which again, the only thing we really care about is that it's negative. So as x approaches -infinity, as x approaches +infinity, well, if it's odd, the y's are going to, one's going to be positive, one's going to be negative. When it's odd with the negative leading coefficient, the end behavior works opposite of the function. So if x is getting smaller, y will get bigger, +infinity. As x is getting bigger, y will approach -infinity. So that finishes up the first part of section 2.3.